Hi everyone, this is Kiranmay from H&S department. Today in this session, we are going to discuss about lasers. One of them is a ruby laser. Under this session, we are going to discuss about the key points of ruby laser, elements of ruby laser, construction, working of it, energy level diagram, and the applications of ruby laser in various fields. First of all, the ruby laser was invented by a scientist called as Mollman in the year of 1960. And this ruby laser is a 3-level solid state laser where the active medium will be in the form of solids. It is a pulsar laser which is having a very high power, about megawatts, with about 10 power nanoseconds of duration. And every pulse will be released at every 10 nanoseconds of duration. Ruby rods are prepared from aluminum oxide doped with 0.05% of chromium by weight, so that some aluminum ions are replaced by chromium ions. So the material by what a ruby rod is prepared is aluminum oxide, in which some of the aluminum ions are replaced by chromium ions, and these chromium ions are responsible for the laser output. Coming to the parts of ruby laser, three important parts, that is active medium, resonant cavity, and pumping system. Active medium, as we had discussed, it is a ruby rod which is in the form of a ruby crystal, which is in the form of a rod of 10 centimeters long and 0.8 centimeters diameter. And the chemical configuration of ruby crystal is aluminum oxide doped with chromium ions by a percentage of 0.05. Coming to the resonant cavity, as we had discussed in the previous sessions, resonant cavity generally it will be of two mirrors which are just placed parallel to each other. Here also we are going to consider two parallel mirrors which are plain, silvered, placed at the flat end faces of the ruby rod A and B. Both the faces are parallel to each other, and these are mounted with two mirrors. One mirror is fully reflecting, which is placed at the end A. Another mirror is partially reflecting, which is placed at the end B. And the ruby rod is surrounded by a cylindrical glass tube through which cool water has been circulated to keep the rod cool. Coming to the pumping system, as it is a solid material, as the active medium is a solid material, here we are going to use optical pumping, for which xenon flash lamp has been used. Whereas the xenon flash lamp will be in the form of a helical in which the ruby rod has been inserted. The flash tube is provided with a suitable power supply. For every several milliseconds, it will give a flash. Coming to the constructional structure, on the screen you can observe there is one gas discharge tube in which a ruby rod has been inserted with two faces, end faces A and B. These two faces are mounted with two mirrors, one at the end A and another at the end B. End A is having fully reflecting mirror and B is having partially reflecting mirror. And this gas discharge tube is being provided with a power supply, and this gas tube is mounted with a xenon flash lamp which will provide flashes at every several milliseconds. And this tube is provided with a cooling system with one inlet and one outlet where cool water is circulated continuously. And once the required intensity is reached, we are supposed to take laser output from the partially reflecting mirror end. So coming to the working of this ruby laser, here we are going to have light from the xenon flash tube, which is followed on a ruby rod. So by absorbing that light energy, the chromium ions of ruby rod will get excited from lower energy level 1 to higher energy level 3. Since this is a 3-level energy system, when the energy is absorbed by the chromium ions, they will get excited from ground E1 to E3. The chromium ions stay there for very short time because E3 is a normal energy state. So the atoms, chromium ions, will stay there for 10 power minus 8 seconds, and they will go for a transition from E3 to E2, which is a non-radiative in nature. Non-radiative means there is no light energy provided over there. But due to the transition from higher energy state E3 to lower energy state E2, energy will be dissipated in the form of heat, uh, uh, heat. So the emitted energy will be in the form of heat energy. So since the heat energy is produced here, to cool the system, only the cool water is circulated around the ruby rod. Once the atoms reach the energy level E2, since E2 is a metastable state, they stay there for longer time, and number of ions in this state goes on increasing while in the ground state goes on decreasing. So in this way, population inversion is created in between E2 energy level to E1 energy level. So when ion passes, so the atoms will accumulate more in the second energy level than comparable to the even energy level, creating population inversion. So when the ions from this E2 energy level passes spontaneously, one photon will be released over there. That photon, by colliding with the partially reflecting mirror and fully reflecting mirror, at some part of time, it will react with, or it will interact with the atoms which are present in the second energy level, causing it to emit fresh photons in phase with the earlier one, which is a stimulated emission transition. So this photon which has been released due to which has been released spontaneously, it travels through the ruby rod, and if it is moving parallel to the axis of the crystal and reflected back forth by the silver ends until it stimulates an excited ion in the level 2 and causes it to emit fresh photon in phase with the earlier photon, which means that a stimulated emission happens. This stimulated transition triggers the laser transition, and the process is repeated again and again. That means the photons which has been released in phase with each other, those are repeatedly sent back into the medium, so that the released photon number will get multiple. When the photon beam becomes sufficiently intensified, such part of it energies through the partially silver end of the crystal, and output is a pulsed end. Here on the screen, you can observe the energy level diagram where from level 1, by absorbing a 560 nanometers of light flash from the xenon flash lamp, at chromium ions got excited from level 1 to level 3, where from level 3 to level 2 it will go for non-radiative transition, where heat energy will be released for the for cooling purpose. We are supposed to send cool water around the ruby rod, and from level 2 to level 1, population inversion is created so that stimulated emission rate will be predominant. At some point of time, due to feedback system, the number of photons produced will reach the required intensity, and a laser transition of 6947 angstroms will be produced using a ruby laser. Coming to the applications of ruby laser, most of the time this will be used for holography, drilling high quality holes, and in the military purpose as a target designator and a range finder, because whatever the output we are getting from the from the ruby laser, it is of very high power. So this will be used for destruction purpose most of the time, and destruction purpose in positive way, that is in the military as a target designator, and then drilling purpose for the holes in industries. These are the certain applications of ruby laser, which is having a very high power output. So most of the time it will be not be used for domestic purpose. It is mostly used for the positive side of destructive purpose. Thank you.